I'm SYAZWANI.
I'm ZAHIRAH.
I'm NADZIRAH.
And today we're going to discuss about nozzle and diffuser.
Okay, we will start with definition. Okay, nozzle is a device that increases the velocity of a fluid at the expense of pressure. And a diffuser is a device that increases the pressure of a fluid by slowing it down. We know that the cross-sectional area of a nozzle decreases in the flow direction for subsonic flows and increase for supersonic flows. The reverse is true for diffuser too. And we know that the rate of heat transfer between the fluid flowing through a nozzle or a diffuser and the surrounding is usually very small. We know that Q equal to 0, and we know that nozzle and diffuser typically involve no work, so W is equal to 0.
What is the difference between
Nozzle and diffuser. Okay, so I would like to explain about the differences between nozzle and diffuser. So firstly, a nozzle is often a pipe or tube of varying cross-sectional area, and it can be used to direct or modify the flow of a liquid or gas, and nozzles are frequently used to control the rate of flow, speed, direction, mass, shape, and the pressure of the stream that emerge from them. In nozzle, velocity of fluid increase on the expense of its pressure energy. And as for a diffuser is actually a mechanical device that is designed to control the characteristic of a fluid at the entrance to a thermodynamic open system. Diffusers are used to slow the fluid's velocity and to enhance its mixing into the surrounding fluid. In contrast, a nozzle is often intended to increase the discharge velocity and to direct the flow in one particular direction.
So what the types?
Okay, for nozzle there are certain types. There are few types of nozzle: spray nozzle, jet nozzle, propelling nozzle, convergent and divergent magnetic nozzle. For convergent nozzle, they are mostly used in aircraft, and while convergent and divergent nozzle mostly used in supersonic aircraft. For diffuser, we usually can find diffuser in our real life applications such as hair dryer. A diffuser is an attachment that is used on hair that is fine coloured or purple. It diffuses the jet of air so that the hair is not blown around while it dries. Other than that, in aroma lamp, it's an electric or candle fluid device which volatilizes essential oil used mixed with water.
So as you said about the application of nozzle and diffuser, so I want to add a little bit about the application. Basically, with nozzle, we can find it in gas stove, ovens, and also vacuum cleaners. For industrial use, we can find it in injection molding machine and extrusion molding machine. And for diffusers, usually diffuser used for ventilation system and air conditioning system. So I'm doing this question about deceleration of air in a diffuser, but I couldn't even start it. Can you help me?
I've already checked this question. So from the question, we can assume that it is a steady flow process since there is no change with time at any point, and thus delta M and delta E is actually 0. And since it is at high temperature and low pressure relative to its critical point, so air is an ideal gas. And then we assume that the potential energy change is 0, and heat transfer and kinetic energy at diffuser exit is negligible, and there are no work interaction. So we assume all those. Okay, to start this question, the first thing it asks the mass flow rate of the air. Okay, so to determine the mass flow rate, we need to find the specific volume of the air first. So this is determined from the ideal gas relation at the inlet condition. We use formula V equal to RT over P. Okay, so since it is given 10 degrees Celsius, so we change it to Kelvin. Just add 273 K plus with 10 and equal to 283 Kelvin. So 0.287 times with 283 Kelvin divided by 80 kilopascal, we will get 1.015 meter cube per kilo. Okay, so the next step is to find the mass flow rate. So the formula of mass flow rate is 1 over volume times velocity times area. Okay, so we use this formula and we'll get 78.8 kg per second for the mass flow rate. So since the flow is steady, the mass flow rate to the entire diffuser remains constant at this value.
So because the energy in is the same with the energy out, so we use the formula mass flow rate in bracket H1 plus V velocity squared over 2 and C at the other side. So and then in the end it becomes H2 equals to H1 minus V squared 2 minus V squared 1 over 2. So at first we have to find H1. So H1, if we refer to their temperature that already given, they already give us 10 degrees Celsius. So we convert it to Kelvin, we become 283 Kelvin. And if we refer to table A17, because 283 doesn't include in the table, so we use the interpolation method, and then we will get 283.14 kilojoule per kg. After we got H1, and then we'll find H2 using the equation that we already got just now. So H2 equals to 283.14 kilojoule per kg minus 0 minus 200 meter per second squared over 2, and then we will get H2 is equal to 303.14 kilojoule per kg. So from table A17, then we will get the temperature corresponding to this enthalpy value is 303 Kelvin. So the result show that the temperature of air increased by about 20 degrees Celsius as it is slowed down in the diffuser. The temperature rise of the air is mainly due to the conversion of kinetic energy to internal energy.
So why don't you guys check the question for nozzle? Okay. Based on the question, we can assume that this is a steady flow process since there is no change with time. And thus, the delta N and delta E is equal to 0. And there is no work interaction in this process, and the potential energy is equal to 0. So, based on the question, it's given that pressure equal to 1.8 megapascal and the temperature is 400 degrees Celsius. So, by referring to table A6, we can get the value for specific volume, which is 0.16849 meter cube per kg, and the enthalpy is 3251.6 kilojoule per kg. So by using the formula of mass flow rate, which is 1 over volume times velocity times area, we can get the value for velocity, which is 42.1 meter per second.
Okay, for question B, they want the exit temperature of the steam, so we must find T2. So before we find T2, we need to find H2 because we don't have that information. So from steady flow system, we can come up with E energy in equal to energy out, which equal to mass flow rate H1 plus V1 squared over 2 equal to heat transfer plus mass flow rate H2 plus V2 squared over 2. Okay, from that equation, we divide all that with mass flow rate and substitute H and we get H2 equal to H1 minus heats out minus V2 squared minus V1 squared over 2. So we substitute all the information that we get from the question and from A, which is H1, Q out, V2 and V1. After that, we will get the answer for the question. We get H2 equal to 3211.9 kilojoule over kilogram, and we have the information of P2, which is 1.4 megapascal, and we got H2. Okay, we refer to table AC to find the T2, but we don't have that information, so we will use the interpolation method. So after use the interpolation method, we will get T2 equal to 378.6 degrees Celsius. That's all from the question.
Thank you.